Okay, so here we have a video recording for homework from exercise 9C. Starting with question 1a, sine 37 degrees cosine 25 degrees plus cosine 37 degrees sine 25 degrees. Now this looks really familiar, sine A cosine B plus cosine A sine B. This is combined to be sine of 37 degrees plus, because this is a plus over here, 25 degrees. So we get sine of 72 degrees, 62. Okay, so next, 1D. Again combine cosine 75 degrees, cosine 24 degrees, plus, take note of the plus, sine 75 degrees, sine 24 degrees. So we see a cosine cosine. I know that it is going to be combined to become a cosine of 75 degrees, but now since this is a plus, I'm going to change the sign, it becomes a minus 24 degrees. So this is combined to be cosine of 51 degrees. And the last question, 1F. So tangent 37 degrees minus tangent 12 degrees. Okay, this is shaping up to look like our addition of the angles for tangent. 1 plus tangent 37 degrees, tangent 12 degrees. So since this is a minus in the numerator, this is a plus. The signs are always opposite for this tangent expansion. So I know that this is going to be tangent of 37 degrees, and we are going to follow the sign in the numerator, minus 12 degrees, combined to become tangent of 25 degrees. So the next question is question 5. For question 5, they are telling us that tangent A is negative 3 over 4. Okay, must quickly know that this is A in quadrant 2 and 4. Then we also have cosine B negative 5 over 13. So quickly at the back of your mind, we know that B in quadrant 2 and quadrant 3. Then they also tell us that both lie between 180 and 360. Okay, since A and B lie between 180 and 360, then we can eliminate quadrant 2 for A and quadrant 2 for angle B. So now we have the quadrants, which means I can draw the triangles out for A in quadrant 4. Anti-clockwise, this is my angle A. So tangent, opposite over adjacent, I've got a 3 over here, I've got a 4. That is a negative sign, it must belong to the 3 because it is found below the x-axis. So this, according to Pythagoras, must be 5. And let's draw the triangle for B. So my angle B, cosine, so we have adjacent, that is 5, over our hypotenuse. Sorry, this is in quadrant 3, okay. We said that it's in quadrant 3, I drew it in the wrong quadrant. So this is B. Adjacent, which is 5, and the hypotenuse 13, the negative sign must belong to the 5 since it is found on the left hand side of the y-axis. So Pythagoras, again, we know that this is going to be 12, and since it is below the horizontal axis, this must be a negative. So for part 1, sine of A plus B, we expand to be sine A cosine B plus sine B cosine A. All these we can get from our triangles. So sine A, opposite, so negative 3 over hypotenuse 5, multiplied by cosine B, adjacent, negative 5 over hypotenuse plus sine of B, negative 12 over 13, and cosine of A, adjacent, over hypotenuse. And our answer in this case will be negative 33 over 65. It is an exact value. No need to round off. So now for part 2, cosine of A minus B. We expand it out, cosine A, cosine B, plus, we change the sign. So sine A, sine B. All these values we can get from the triangle. So cosine A, cosine B, plus sine A, and sine B. Answer in this case, 16 over 65. And for the third one, tangent A plus B. So tangent A, we follow the sign, plus tangent B over 1 minus tangent A tangent B. So from our triangle, tangent A, the adjacent, 4 over, opposite over adjacent, so negative 3 over 4, that's our tangent A, plus our tangent B, opposite, so negative 12 over negative 5, divided by 1 minus, the same fractions are being copied down, so negative over negative is simply positive, and this gives me 33 over 56. So these questions are very common exam questions. You need to know how to do them. Okay, another type of question. 9. A and B are both acute, so A and B are in quadrant 1. They tell us that sine A minus B is 16 over 65. At the same time, sine A cosine B is 36 over 65. Nothing we can do to this, but for this we can expand. Sine A cosine B, follow the sign, minus sine B cosine A. This is 16 over 65. And we see that, hey, sine A cosine B has appeared. Sine A cosine B. This is 36 over 65 minus sine B cosine A. 16 over 65. So what this means is that we can now answer part 1 to find cosine B sine A. Cosine A sine B. Sine B, make it the subject. We have 36 over 65 minus 16 over 65, leaving us with 20 over 65, which is 4 over 13. Now for part 2, we require sine of A plus B, which we can expand. Sine A cosine B, this time is a plus. We follow the sign for the expansions on sine. So we have sine B cosine A. Now sine A cosine B was given to be 36 over 65. Sine B cosine A we found in part 1 to be 4 over 13. So it's added to give us 56 over 65. And for the third part, 3 tangent A cotangent B. In our question so far, we haven't found any values for tangent A or tangent B. So we can rewrite this into its sine and cosine forms. So 3, tangent A becomes sine A over cosine A. Now cotangent B becomes cosine B over sine B. Then we can group all the numerators together. 3 times of sine A cosine B divided by cosine A sine B. All these should be familiar already. Sine A cosine B, it was given to be 36 over 65. 3 times of 36 over 65 divided by cosine A sine B, found in part 1, 4 over 13. Simplify it, and we have 27 over 5.